Hello, good morning to all and welcome to this current module which is Prefab. So today I Kusum Chaudhary, Assistant Professor in School of Architecture, Galgotias University. So today we will discuss about the pre-stressed concrete. It is the continuation lecture of the previous which were on the prefabrication. So let's start today lecture. So here are given a few prerequisites. First one is industrial construction, structural steel works, prefabrication system, open prefab system, large panel prefab system, joints, precasting methods, materials, on-site and off-site prefabrication, components and etc. So objectives of this current module is to develop and include universal design principle. Second is the designing in lightweight construction, concrete, pre-tensioning, post-tensioning. Third is the defects and remedies. So these are the objective of this module. So on this slide, here we have content of this lecture. First is introduction to pre-stress, basic concept of pre-stress, terminologies of pre-stress, advantage and limitations of pre-stress, and types of sections. What is mean by the pre-tensioning and post-tensioning, and questions for assignment at the end of this lecture, and the references. So let's start with the introduction. What is pre-stress? A pre-stressed concrete structure is different from a conventional reinforced concrete structure due to the application of an initial load on the structure prior to its use. Internal stresses are induced in a member to counteract the external stresses which are developed due to the external load or service loads. The concept of pre-stressing existed before the application in concrete. For example, here you can see in this diagram, this is a reinforced concrete diagram, cracked with defection under dead load and full service load. So here you can see the due to the external load, this part get cracked, and here you can see the example of the pre-stressed concrete uncracked with likely camber under dead load and pre-stress. So this part using after the pre-stressing concrete, so it can bear the that load, and this part cannot bear that types of load, so it will get cracked. So in this slide, here you can see the basic concept of pre-stress, force fitting of metal band on wooden barrel. So here you can see this member, it is tied with the help of the metal band which is induced a state of initially hoop compression to counteract the hoop tension caused by filling of liquid in the barrel. So this is the basic concept of understanding the pre-stress. Here are given another basic concept of pre-stress for better understanding about the pre-stress. Pre-stress the spokes in a bicycle wheel. So the pre-tension of a spoke in a bicycle wheel is applied to such as an extent that there will always be a residual tension in the spoke. So these spokes are creating the tension. Pre-stressing of structure was introduced in the late 19th century. The following sketches explain the application of pre-stress. Here you can see place of stretch mild steel rod prior to concreting, and after this we have to place the concrete in this member and release the tension and cut the rod after concreting. So before placing the concrete, basically we are applying the this steel bar, and then after that we have to tensionate this bar, and after that we have to place the concrete in this part. And after it we can cut the rod after concreting. So this is the pre-stressing of concrete beam by mild steel rod. In this slide, here we have some terminologies which is used in pre-stressed. First one is tandon, a stretch element used in a concrete member of a structure to impart pre-stress to the concrete. That is known as the tandon. Second is the encroach, a device generally used to enable the tandon to impart and maintain pre-stress in concrete. That is anchorage. Pre-tensioning, a method of pre-stressing concrete in which the tendons are tensionoid before the concrete is placed. As I already mentioned in the previous slide, pre-stressing method. In this method, the concrete is introduced by bond between steel and concrete. So this method is known as the pre-tensioning. Now is the post-tensioning, a method of pre-stressing concrete by tensioning the tendon against hardened concrete. In this method, the pre-stress is imparted to concrete by bearing. So basically, major difference in the pre-stress, pre-tensioning and the post-tensioning is in pre-tensioning method, we are applying the tension in the steel bar before placing the concrete in the member, and the post-tensioning, here we are applying the tensioning in the bars after placing the and after hardening the concrete. So these are the majorly difference between the pre-tensioning and the post-tensioning. Other terminologies are wires, strands, tendon, cable, bars. Tendon already we have discussed in the previous slide, and the wires, pre-stressing wire is a single unit made of steel. Strands, 2 or 3 or 7 wires are bound to form a pre-stressing strand. Cable, a group of tendons form a pre-stressing cable. Bar, a tendon can be made up of a single steel bar. The diameter of a bar is much larger than that of a wire. So next is bonded tendon and unbonded tendon. Where there is a adequate bond between the pre-stressing tendon and concrete, it is called the bonded tendon, and where there is no bond between the pre-stressing tendon and concrete, it is called the unbonded tendon. So here we have the advantages of the pre-stressing. The pre-stressing of a concrete has several advantages as compared to traditional reinforced concrete without pre-stressing. A fully pre-stressed concrete member is usually subjected to compression during service life. And first one is the reduction of steel corrosion, increase in durability. Second is the high span to depth ratio. If we use the pre-stressing method, so large span possible with pre-stressing, like bridges, building with large column free spaces. So in these cases we can use the pre-stressing method. Next is the typically value of span to depth ratio in slab are given below. So non pre-stressed slab, अगर if we will use the non pre-stressed slab, so the ratio will be 28:1, and if we will use the pre-stressed slab method, so we can take the span up to 45:1. So here is the possibility to use the more span as compared to the non pre-stressed method. Next is for the same span, less depth compared to RC member reduction, and in that case we can reduction the self weight of the concrete and the structural part, suitable for precast construction. The advantage of precast construction are like it can be rapid construction, better quality control, and reduce the maintenance, suitable for repetitive construction, multiple use of formwork, reduction of formwork, and availability of the standard shape. So these are the advantages of pre-stressing concrete. If we have advantages of pre-stressing, so as well as along the advantages we have some limitations with the pre-stressing method. First one is the Pre-stressing needs skilled technology, hence it is not as common as reinforced concrete. So we have to take care about it, and the use of high strength material is costly. So we have to take care about the cost also. There is additional cost in auxiliary equipments. There is need for quality control in inspections. So we have to take care about all these factors. So here are given some types of precast section. As you can see, first one is the T section. This is called the double T section as it is clear by its shape. And here you can see the hollow core. This is the piles. These are the L section, inverted T section, and I grider sections. So these are the typical precast members. So here you can see the pre-tensioning example. So what is meant by the pre-tensioning? As it is clear by its name, we are applied the tensioning in the tendons before placing the concrete. The pre-compression is transmitted from steel to concrete through bond over the transmission length near the end. Here you can see the example of the electrical pole, which are the example of the pre-tensioning concrete. So in this slide you can see the example of the post-tensioning method. Basically the tension is applied to the tendon after hardening of the concrete. That method is known as the post-tensioning. The pre-compression is transmitted from steel to concrete by anchorage device. The following figure shows a post-tension grider of a bridge. So we are applying the tensionoid on the tendon after the placing of the concrete. So that is why it is called the post-tensioning method. So on this slide we have some questions for the assignment. So first one is the what is difference between reinforced concrete and the pre-stressed concrete? What is the difference between pre-tensioning and post-tensioning? Explain with suitable sketches. And the question third is that you have to define the following terminologies: tendon, anchorage, bar, cables, bonded tendon and the unbonded tendon. So you have to solve all these. So here are given few references related to this lecture. You can use these references for more detail about the pre-stressed concrete methods. At the end, I would like to thanks to everyone for listening and watching this